Okay, 5.2 is about congruent polygons. Sorry, my previous video that I started kind of got messed up, so I wanted to start over. So we're going to talk about corresponding parts first, okay? And coming off of chapter 4, talking about translations and reflections and rotations, those were all rigid motions. So a corresponding part is something that a rigid motion maps each part of a figure to a corresponding part of a congruent figure. Okay, so if we read here, lots to read actually. It says when triangle DEF is the image of triangle ABC after a rigid motion or a composition of rigid motions, which means more than one, you can write congruent statements for the corresponding angles and corresponding sides. Okay, you can tell which angles match up because they have the one little arc. The next one has 2, and the next one has 3. Same thing with the little hash marks 1, 2, and 3. Okay, so you can tell which ones go together. So then from there, when you write a congruent statement for 2 polygons, always list the corresponding vertices in the same order. You can write congruent statements in more than one way. Okay, 2 possible congruent statements for the triangles above are triangle ABC is congruent to triangle DEF, or triangle BCA is congruent to triangle EFD. So notice, like, I always tell them, like, look at A has 1. So basically, you can name your first one whatever you want. So like, say if I'm looking at this, I'm going to call it triangle ABC. Okay, well then whenever I go to write congruent 2, then I have to be careful and I have to look, okay, what matches up with A? Well, that's D. Okay, what matches up with B? That's E. And what matches up with C? And that's F, and so on from there. Okay, so that'll help you make sure that you're getting those corresponding parts. Okay, same thing with corresponding sides. Make sure you write them in the same order as well. I guess I should go back and talk about that. So if I go from A to B, so that was from 1 little arc to 3 arcs, I need to go from 1 arc to 3 arcs here. Okay, and look at that. Okay, so again, it has to be in the same order. Corresponding angles is a little bit more simple because you are, in this case, I guess I should say, you just have 1 letter. Okay, but if you are using 3 letters, you need to make sure all 3 of those letters match up, kind of like whenever you're talking about the triangle down here. Okay, so then we have when all the corresponding parts of 2 triangles are congruent, you can show that the triangles are congruent. Using the triangles above, first translate triangle ABC so that point A maps to point D. This translation maps triangle ABC to triangle DB prime C prime. Next, rotate triangle DB prime C prime, sorry that's hard to say, counterclockwise through angle C prime DF so that the image of segment DC prime coincides with, that's a ray, with ray DF, okay? Again, it's basically just showing you how, I know that this gets really wordy, so I don't want to just keep confusing you more. It's basically showing you how I can move this on top of this one, okay? So I translated it, which I know is a rigid motion, okay? And then I rotated it, okay? And then I reflect it over that line, so then it maps right on top of each other, okay? And that's what basically all of that's saying, so I'm not going to keep reading the more confusing words, I guess. I just explain it in my own words, okay? So again, so to show that 2 triangles are congruent is sufficient to show that their corresponding parts are congruent. In general, this is true for all polygons, okay? So that last part is, okay, important. You want to show that their corresponding parts are congruent, okay? To make 2 triangles congruent, you show that their corresponding parts are congruent. All right, so let's go ahead and turn the page and get to some actual problems here. Okay, so in example 1, it says write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Okay, so I'm going to put triangle JKL is congruent to triangle TSR. Okay, so then I have angle J is congruent to angle T. Okay, again, I went from J, K to L, so then I have to go 2, to 3 to 1, just like I did on the first one, okay? Then J matches up with T, then K is S, and L is congruent to angle R, okay? Then I also need to do these segments, okay? Since it's a triangle, you know you should have 3 angles and 3 segments, okay? So the segments would be, if I go from J to K, looking at my picture, then I need to go from T to S. If I go K to L, and another way you can think of this is I go J to K, that matches up with TS. If I go KL, that's going to match up with SR. Okay, so in this case, since I have this first one done, sometimes they will give that first one to you, and you just have to do this part. I can use that to help me find my answer, okay? And just go in that. So then L to J matches up with R to T. Okay, and I wouldn't even have to look at the picture then, okay? I would in this case just to double check that I didn't make an error here, but you can tell that that matches up if you want to go ahead and compare that. Okay, so example 2, using properties of congruent figures. In the diagram, DEF is congruent to SPQR. Find the value of X. Okay, so for part A, okay, I see X is up here, okay, and QR is the last 2, so that matches up with FG. So QR is equal to FG, okay? Or you can say that the segments are congruent, which means then that the lengths are equal. So then I'm going to replace that with what I know. So 2x minus 4 is equal to 12. And then I'm going to add 4. 2x equals 16. So x is equal to 8. Okay, then for part B, find the value of y. Okay, I see y right here, which is angle Q. So that's the third one. So then the third one over here is angle F. Angle F is 68. So I know 6y plus x equals 68. I know x is now 8. I don't know where I wrote x, 68. Okay, subtract 8, 6y equals 60. So y is equal to 10. And again, the reason why I knew this was I knew that angle Q was congruent to angle F, which means that the measure of angle Q equals the measure of angle F. Okay, if you want to add that there to the top. Okay, so the next one, example 3, it says you divide the wall into orange and blue sections along segment JK. No, you can't see the orange and blue here, but you can tell one is significantly darker than the other. So we'll say this one is orange and this one is blue, okay? Doesn't really matter. Will the sections of the wall be the same size and shape? Explain, okay? So basically, I have a 4-sided figure right now, and in order to be able to say that these shapes are congruent, I need all 4 angles equal to all 4 angles, and all 4 sides equal to all 4 sides, okay? So I know that looking at this picture that angle A is congruent to angle C, and angle D is congruent to angle B, because all right angles are congruent, okay? From here, I know that segment AB is parallel to segment DC because of lines, that's an L, sorry, lines perpendicular to a transversal theorem. Okay, they're both perpendicular to the same line. Okay, so I know then that they have to be parallel. Okay, parallel, parallel. All right, so then from here, I know then that angle 1 is congruent to angle 4, so I know I should go ahead and fill this in. I can fill in this is parallel, this is parallel, okay? So all those alternate interior angles, remember, outlines a Z here, okay? So I know then that 1 and 4 are the same, and I know that 2 and 3 are the same. Alternate interior angles theorem. Okay. Then the next part, I know that segment AJ is congruent to CK. And I know that KD is congruent to JB. And I know that DA is congruent to BC. Okay, because all of these are already marked for us. So all marked in diagram. Okay, trying to show you where I got all of this from. Okay, and then lastly, I know that JK, segment JK, is congruent to itself. Okay, but since this is getting flipped upside down, I have to flip my letter order. Okay, it's JK on the left-hand side, but then if I go on the right-hand side, it's from K to J that matches up. Remember, because 1 matches up with 4, 2 matches up with 3. Okay, and that is called reflexive whenever you are congruent to yourself. Okay, it's like looking in a mirror, same thing on both sides. Okay, so then the last thing then is, so all corresponding sides are congruent. Therefore, and we already had the angles over here, therefore AJKD, make sure you're following the same order then, is congruent to CKJB. And yes, the two sections will be same size and shape. Okay? All right, you can go ahead and turn the page. All right, last page here, theorem 5.3 is the properties of triangle congruence, okay? So again, this is for reflexive, symmetric, and transitive. It also works for triangles, okay? So for any triangle ABC, you know that triangle ABC is congruent to triangle ABC, okay? It's got to be congruent to itself. Then symmetric is if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. Symmetric just flips the order. And lastly, transitive, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. Okay? Theorem 5.4 is the third angles theorem. We have if two angles of a triangle are congruent to two angles of another triangle, then the third angles are also congruent. Okay, so over here we have if angle A is congruent to angle D and angle B is congruent to angle E, then you know that angle C also has to be equal to angle F. Again, because they both add up to be 180. If the other two are the exact same, then that means that the last one also has to be the same for them to be equal to each other and add up properly to that 180. Okay, so in example 4, using the third angles theorem, okay, I kind of like to think of this as two different triangles, okay? You know that we're using the third angles theorem here. Okay, so I'm going to redraw this one over here. So I know that 45 is up here, okay, because this has one mark, this has one mark. And down here, I see that this one has 2 marks, which is 30. So that means that this one also is 30. So then what is remaining, I'm going to label X. Okay, so I know that angle ACD is congruent to, if I started at A, I start with B. If I went to C, then I go to D, and then back to C. Okay, and that is by the third angles theorem. Okay, or you can say 5.4 is fine too. So then I know that the measure of angle ACD is equal to 180 minus 30 minus 45, which gives me 105. Okay, so then I know that the measure of angle BDC is also equal to 105 degrees. Okay? All right, and the last one, it says use the information in the figure to prove that triangle ACD is congruent to triangle CAB. Okay, so I have my statements and my reasons. Okay, so what is given here is going to be what's shown to you in the picture. So I know that segment AD is congruent to segment BC. Okay, it's important that they go in that order. And you know what? I wrote it in the wrong order. It should be CB. I would have gotten a point taken away there, so you have to be careful. And I know that DC is congruent to BA. I know that angle, let's call it DAC, is congruent to BCA. And I also see that angle ACD is congruent to CAB. Okay, all of that was given to me in my picture. Okay, so here I'm looking at this. I have a side, an angle, and an angle. So that means that I'm missing one more side and one more angle because I have a triangle, so I have 3 sides and 3 angles. Okay, so I know that my last side could be this side right here. That's an easy one to knock it out right out of the way. So AC is congruent to, it does flip. Okay, I know it doesn't really look like it, but if you look down here, I have 1 and 1 up here. So that means that it needs to be CA. That is called reflexive. Okay, so there's another side. So I'm done with my 3 sides. Now I need one more angle. Well, I know that angle D would have to be congruent to angle B by the third angles theorem. Okay, and so then that was my last angle. So I have 3 angles and 3 sides. So then I know that triangle, I'm going to call it ACD, is congruent to triangle CAB, and it is all corresponding parts are congruent. Okay, so those are maybe some things that I need to add to our proofs list as reasons that you can use. So make sure you make note of those, of when I use them and why I use them. Okay, if you have any questions, please let me know, but this should give you a good start on your assignment.